Static routing. Routing is at the core of every data network, moving information across an internetwork from source to destination. Routers are the devices responsible for the transfer of packets from one network to the next. Routers learn about remote networks either dynamically using routing protocols or manually using static routes. In many cases, routers use a combination of both dynamic routing protocols and static routes. This chapter focuses on static routing. Static routes are very common and do not require the same amount of processing and overhead as we will see with dynamic routing protocols. In this chapter, we will follow a sample topology as we configure static routes and learn troubleshooting techniques. In the process, we will examine several key iOS commands and the results they display. We will also introduce the routing table using both directly connected networks and static routes. As you work through the packet tracer activities associated with these commands, take the time to experiment with the commands and examine the results. Reading the routing tables will soon become second nature. The router is a special-purpose computer that plays a key role in the operation of any data network. Routers are primarily responsible for interconnecting networks by determining the best path to send packet, forwarding packets toward their destination. Routers perform packet forwarding by learning about remote networks and maintaining routing information. The router is the junction or intersection that connects multiple IP networks. The router's primary forwarding decision is based on Layer 3 information, the destination IP address. The router's routing table is used to find the best match between the destination IP of a packet and a network address in the routing table. The routing table will ultimately determine the exit interface to forward the packet, and the router will encapsulate that packet in the appropriated data link frame for that outgoing interface. The figure shows the topology used in this chapter. The topology consists of three routers, labeled R1, R2, and R3. Routers R1 and R2 are connected through one WAN link, and routers R2 and R3 are connected through another WAN link. Each router is connected to a different Ethernet LAN, represented by a switch and a PC. Each router in this example is a Cisco 1841. A Cisco 1841 router has the following interfaces: two fast Ethernet interfaces, Fast Ethernet 00ths and Fast Ethernet 01sts, two serial interfaces, Serial 0/0/0 and Serial 0/0/1. The interfaces on your routers may vary from those on the 1841, but you should be able to follow the commands in this chapter with some slight modifications and complete the hands-on labs. In addition, packet tracer activities are available throughout the discussion of static routing so that you can practice skills as they are presented. Router connections. Connecting a router to a network requires a router interface connector to be coupled with a cable connector. Cisco routers support many different connector types. Serial connectors. For WAN connections, Cisco routers support the EIA-TIA 232, EIA-TIA 449, V35, X21, and EIA-TIA 530, standards for serial connections, as shown. Memorizing these connection types is not important. Just know that a router has a DB60 port that can support 5 different cabling standards. Because 5 different cable types are supported with this port, the port is sometimes called a 5-in-1 serial port. The other end of the serial cable is fitted with a connector that is appropriate to one of the 5 possible standards. Note: the documentation for the device to which you want to connect should indicate the standard for that device. Newer routers support the Smart Serial interface that allows for more data to be forwarded across fewer cable pins. The serial end of the Smart Serial cable is a 26-pin connector. It is much smaller than the DB60 connector used to connect to a 5-in-1 serial port. These transition cables support the same 5 serial standards and are available in either DTE or DCE configurations. These cable designations are only important to you when configuring your lab equipment to simulate a real-world environment. In a production setting, the cable type is determined for you by the WAN service you are using. Ethernet connectors. A different connector is used in an Ethernet-based LAN environment. An RJ45 connector for the unshielded twisted pair UTP cable is the most common connector used to connect LAN interfaces. At each end of an RJ45 cable, you should be able to see 8 colored strips, or pins. An Ethernet cable uses pins 1, 2, 3, and 6 for transmitting and receiving data. Two types of cables can be used with Ethernet LAN interfaces. A straight-through, or patch cable, with the order of the colored pins the same on each end of the cable. A crossover cable, with pin 1 connected to pin 3, and pin 2 connected to pin 6. Straight-through cables are used for switch to router, switch to PC, hub to PC, hub to server. Crossover cables are used for switch to switch, PC to PC, switch to hub, hub to hub, router to router, router to server.